We spend roughly 2 hours every single night plunged into a totally bizarre, hallucinated reality. Welcome to The Explainer. I'm so thrilled you're joining us today. We're going to take a super fascinating journey into one of the most universal, yet honestly deeply mysterious experiences of human life, dreaming. For millennia, we've been completely captivated by the wild mental gymnastics that happen the second we close our eyes. So we're going to trace the incredible arc of this curiosity, starting all the way back with foundational, historical interpretations, and then zooming right into the cutting-edge neuroscience and actual real-world dream engineering happening in labs today.
Okay, let's dive right into this. Here's our roadmap. 1. Decoding the dream mystery. 2. The neuroscience of dreams. 3. The emotional thermostat. 4. Inside the lucid brain. And 5. The era of dream engineering. It's a really logical flow from a century of psychoanalysis straight into futuristic tech.
Section 1. Decoding the dream mystery. To truly grasp where the science is today, we first kind of have to look back at how we spent the 20th century trying to decode this whole psychological puzzle.
For decades, the whole debate really centered around two towering figures you've definitely heard of, Sigmund Freud and Carl Jung. So Freud famously argued that dreams were basically disguised fulfillments of repressed, mostly sexual wishes. In his view, your mind is literally hiding unacceptable desires behind symbols just so your sleep isn't disturbed. Jung, on the flip side, totally disagreed. He viewed dreams not as some sneaky disguise, but as direct communication. For Jung, dreams revealed unconscious truths and used these universal archetypes to guide our personal growth. And it's actually super fascinating to note that modern dream science, while it definitely acknowledges Freud's ideas on repression, leans a bit more toward Jung's flexible framework. It views dreaming as a dynamic space for emotional processing and problem solving, rather than just, a closet for forbidden wishes.
Now that psychological history is incredibly rich, but it leaves us staring at one massive, lingering question. What is the brain actually doing while we dream? It's time to pivot away from subjective psychology and look directly at the objective, biological reality of your sleeping brain.
Section 2. The neuroscience of dreams. We are officially entering the realm of the rapid eye movement, or REM, sleep phase.
This is the biological theater where our most vivid dreams take place. And during REM sleep, your brain is far from turned off. In fact, it's highly active, but in a really specific, almost strange way. The amygdala, which is our emotional center, and the hippocampus, our memory hub, show intensely heightened engagement. They are fully on. But at the exact same time, the prefrontal cortex, the part of your brain responsible for logic, rational thought, and decision-making, exhibits severely reduced activity. It's basically powered down. So this brilliantly illustrates exactly why our dreams feel so incredibly real and emotionally intense, yet they feature these completely surreal, disjointed narratives where physics and logic literally just do not apply.
Now, what's really interesting here is what drives this bizarre brain state. It's a drastic neurochemical shift. Acetylcholine gets a massive boost, actively driving REM sleep and those super vivid visual experiences. Meanwhile, serotonin and norepinephrine, the neurotransmitters tightly linked to arousal, stress, and strict reality monitoring, are completely suppressed. You are, quite literally, chemically blocked from applying waking logic to your dream environment.
Section 3. The emotional thermostat. Understanding that the brain is chemically altered and emotionally fired up during REM leads us to a massive breakthrough in why we actually dream at all.
And this brings us to a total game changer of a concept proposed by sleep researcher Matthew P. Walker. It's called the SFSR model, which stands for sleep to forget, sleep to remember. Because your brain is completely devoid of those aminergic stress chemicals we just talked about, specifically norepinephrine, it can safely reactivate and reprocess really difficult emotional events from your day. It's essentially a built-in overnight therapy session. The brain processes the memory in this perfectly safe, stress-free chemical environment, allowing it to untangle the raw, painful emotion from the actual factual memory.
The absolutely crucial takeaway here is this. We sleep to forget the emotional tone, yet we sleep to remember the memory itself. Without this nightly thermostat, the emotional blanket of our memories would just remain overwhelmingly intense. Imagine if every single time you remembered a stressful event, you felt the exact same level of panic as when it actually happened. Well, dreams act as a thermostat that cools those memories down.
Section 4. Inside the lucid brain. Once scientists mapped out why dreams happen, the next logical question was, well, can we study them from the inside? This brings us to a highly energetic and exciting frontier, lucid dreaming. This is the incredible phenomenon where you basically wake up inside the dream. You become completely aware that you're dreaming while your body remains physiologically asleep, which actually allows for conscious control. Now, this isn't a new concept by any stretch. Even the ancient Greek philosopher Aristotle wrote about it, but for the longest time, it was brushed off as a myth by many scientists, at least until it was finally physiologically validated in the late 1970s.
So how did they validate it? Through this absolutely incredible eye signaling technique. Because our eyes are literally the only part of our body not paralyzed during REM sleep, researchers ask lucid dreamers to use their eyes to send a signal to the waking world. When a subject realizes they are dreaming, they execute a highly precise sequence. They look all the way to the left, then to the right, twice in a row. It is a literal Morse code from the dream world. This clever trick allows a dreaming person to essentially timestamp their conscious actions on a polysomnograph, the machine monitoring their brain and body data right there in the sleep lab.
And when scientists look at the brainwaves of someone signaling lucidity, things get really wild. While EEG studies do have some mixed results depending on the methods used, we see some very distinct markers. We're talking increased parietal beta power and potential gamma activity, which, by the way, are brainwaves typically associated with waking alertness. And this happens right alongside reduced delta power, the classic signature of deep sleep. Basically, what you're looking at is a bizarre hybrid physiological signature of a brain shifting right into self-awareness. It's displaying increased cortical neural integration as the dreamer moves from a passive state into full-blown lucidity.
Section 5. The Era of Dream Engineering. Which brings us to our final and frankly awe-inspiring segment. If we know the biology, and we know we can communicate from inside a dream, can scientists actually manipulate the dream state from the outside? To do this, scientists use a methodology called Targeted Memory Reactivation, or TMR. In a landmark study out of Northwestern University, researchers gave participants these really tricky brain teaser puzzles to solve while awake, and they paired each puzzle with a totally unique soundtrack. Now, most of the puzzles were left unsolved. Then, while those participants were deep in REM sleep, the researchers quietly played the unique soundtracks associated with the unsolved puzzles. They were literally priming the sleeping brain with audio cues.
And this brilliantly illustrates the sheer power of the sleeping mind. Are you ready for this? A massive 75% of the participants actually dreamed about the specific puzzles they had been primed with when the sounds were played during their REM sleep. No way, right? The audio cues effectively guided the entire narrative of their dreams.
But wait, it gets even better. Did dreaming about it actually help them solve the puzzles? The answer is a staggering yes. For the puzzles that were cued during sleep, the post-sleep solving success rate skyrocketed to 42%, compared to only 17% for the puzzles that were not cued. The dreamers were actually doing complex, creative problem-solving in their sleep.
Researcher Karen Concoli noted just how incredibly powerful this effect really was. For example, she shared this fascinating anecdote about one dreamer who was cued with a trees audio puzzle. Now, even without being a lucid dreamer, the person heard the cue, woke up from a dream where they were wandering through a dense forest, and boom, subsequently solved the puzzle. The brain actively incorporated the waking world's audio right into the dream's narrative to crack the code.
Senior author Ken Powler sums up the incredible potential of this research perfectly. He points out that this isn't just about parlor tricks in a lab. By understanding how to harness sleep engineering, we can actively use our sleep to boost our creativity, process difficult emotions, and genuinely maintain our mental health. I mean, we spend a third of our lives asleep. It's about time we recognize it as an active, vital tool for our waking lives.
So as we wrap up this explainer, I really want to leave you with one lingering thought. From Freud's couch to high-tech sleep labs, we have come incredibly far in mastering the mystery of the night. If we can literally engineer dreams to solve puzzles and heal emotional wounds in a lab setting, what untapped potential lies in your sleep tonight? I really hope this sparks your curiosity to pay just a little more attention the next time you close your eyes. Thank you so much for learning with me today.